Hello, this is Tom Zeppeveld from Graphileon with a demo of InterActor being used to do some research on different scenarios in a network. And the scenario consists of the following. Imagine that you have a network of nodes, which can be applications or roads or whatever you want to represent in a graph. And a number of those nodes are inactive and the other ones are active. And what you want to do is to select a start point and an end point of and find out what is the shortest path without using the inactive nodes. Another part of the scenario is that you want to use this in a multi-user environment. So you have multiple people at the same time who are doing this research of scenarios. So that means that any setting for a specific scenario, you cannot store to the graph, because otherwise it would influence the scenarios of others as well. So it's a part that is done purely virtually or in the visualization, and another part is done in the store. So I imagine that I would select here a starting node and an end node, and I would calculate the shortest path. Okay, now it's displayed over here, and together with the length, and here it is drawn in the source graph itself. You see that the styling indicates the shortest path, and also the start and the end node. That can be done thanks to the styling, the cascading styling that we have built in our InterActor network view. So here you have the nodes that are or the styles that are are used. For instance, we have a style for the relationships. So normal relationships is styled like this, like the JSON indicates on at the bottom. But when I have another styling with a property on shortest path equals 1, then part of the styling is changed, and because it's cascading, it can easily be merged into one style. And the same is done, for instance, for this start node of this end node, which is active. So I have my node styling, I have my active styling, which sets the line width and the line color, and the fact that it's end node, it is it sets the fill color. So this is what is currently the current path, the shortest path. So if I now would deactivate node N, as you can see, it now draws two paths. Apparently, I have two shortest paths, and this means that if I would deactivate one of those nodes, for instance, node J, then only one path would remain. And if I can even make it a little bit more complex, if I'm going to deactivate this node, then you get another shortest path from length 14, and which is displayed in the graph as well. So since this is built in InterActor, I can also display what is the logic behind it. So there is logic to create the initial graph. There's logic to add these context menus. There is logic to display the shortest path in a second network view, and of course the logic to feedback the shortest path to the source graph. So let's have a look at it. So this is the entire logic. I have my two network views over here. I have a number of Neo4j cipher queries. So the first cipher query, it's just very simple. It returns the 26 application nodes, and it doesn't return any relations. But since in my network view I have a setting, one of the settings is autocomplete status is true. So it auto-completes. Here I have my context menus. So for instance, this context menu is the node that I do the right click on. It's my target, and I have a caption switch active, and this params node property means that on this trigger it feeds this parameter to this cipher query. So here I have the node, the parameter, and then the node is changed in the sense that it switches the properties, the active property from 0 to 1 all the way around, and it's fed back. It's returned as a node, and the node is returned if the query is successful to the network view. So that makes that the styling changes as well. So I can also set the start and the end node, which are those queries. And then when this function is updated, so for instance, when a node is switched from active to inactive, it has a function updated trigger, and that function updated trigger it sets a params node, so a node's parameter for the next query, but it also adds the relations to a path. So, and a path is something that goes with the flow of the program, and it can be used at a later stage. So this params nodes, so these are the nodes that are this params node. So I have this array of nodes, and from that array of nodes, and which really represent the nodes as they are in the visualization, I can extract the IDs of the nodes that are not active, but also the start and the end node, and that one is used here in my all shortest path function. So I get all the shortest path from start to end, where none of the nodes is in the set of inactive nodes, and it returns the path and the path length. So that one is sent to the success trigger to this network view, which represents, in fact, is this network view, and also it recalculates all the status of the relationships in my source graph. If I look at this query, so I get all the relationships all in the shortest path, but also all the relationships, and I set the on shortest path property depending on whether one is in the relationships in the set of shortest path relationships, and that one is fed back into the original graph, and that makes that the settings in the this one has on SP equals 1, and that influences the styling using the mechanism I explained before. So this is the first scenario thing. Of course, you can imagine that you also have scenarios where you do not have an end node, you only have a starting node, and then you want to display which nodes can you reach through the through paths that do not go through inactive nodes. Or the other way around, you just have an end node, and you want to know from where can I reach that end node. But those demos will be subject of subsequent videos. Thank you very much for watching, and have a nice day.